Integrating new technology into existing systems often feels like trying to assemble IKEA furniture with just a vague picture.
Yeah, I know that
But
feeling.
imagine that problem multiplied by like 1,000, and you start to grasp the MXN problem in AI.
Exactly.
You have different AI models, maybe one for understanding text, another for writing code,
Yeah.
a third for spotting trends in data.
Right.
And you need them to connect seamlessly to end different data sources, APIs, and crucial enterprise services.
And the result, it's this tangled web of custom glue code. It's slow to build, incredibly expensive to maintain, and just almost impossible to scale.
Yeah, it's been a massive bottleneck, really costing businesses countless hours and dollars.
A huge pain point.
But what if there was a universal translator for AI? A solution so elegant it's being hailed as the USB-C for AI.
That's the promise.
That's precisely what the Model Context Protocol, or MCP, aims to deliver. Introduced by Anthropic back in November 2024, MCP is designed as an open, universal, and model-agnostic standard interface.
And the adoption has been pretty quick. You've got major players like OpenAI, Google DeepMind, Microsoft all getting on board. It's rapidly becoming a core building block.
It really seems foundational.
Well, what's truly exciting here, I think, is how MCP fosters a genuine plug-and-play ecosystem.
Plug and play, okay.
Yeah, and this isn't just about making things simpler, though it does that. It's fundamentally reshaping how we design intelligent systems.
How so?
Instead of trying to build one giant AI brain that does everything, which is incredibly difficult,
Right.
we're moving towards what we call an agentic AI mesh. Think of it like a highly specialized, collaborative team of AIs. Each one brings its unique skills to the table.
An agentic mesh.
Yeah.
Like that. A team of specialized AIs.
Exactly, working together.
And to help you, the listener, sort of navigate this transformative shift, we've put together the MCP framework. Consider it your essential AI blueprint. It deconstructs these complex AI pipelines into three distinct but deeply interconnected layers that align perfectly with the protocol's core ideas. Okay, let's unpack this.
Let's do it.
So the MCP framework, it's structured into these three clear layers. First, there's M for model.
Okay.
This encompasses the smarts, the decision-making, the invocation logic that empowers an AI to actually take action.
Got it. The doing part.
Then we move to C for context. This provides the AI's senses, you could say. All the mechanisms for situational understanding, memory, accessing external knowledge.
The knowing part.
Exactly. And finally, there's P for protocol. This establishes the foundational input-output rules, the communication architecture, basically allowing everything to talk to everything else smoothly.
The connecting part. And that's precisely why this layered approach is so powerful. Each layer maps directly to MCP's fundamental components.
Okay.
So for the protocol P layer, we're talking about the client-server architecture, the JSON-RPC messaging standard, and the choice of transport methods like STDIO or HTTP with server-send events. This is where the core communication rules are set.
The rules of engagement.
Exactly. For the context C layer, the key primitives are resources and prompts. This is how the AI perceives and understands its world, how it gains the knowledge it needs.
Right, the perception.
And finally, for the Model M layer, the crucial primitive is tools. This is what gives the AI the power to perform actions and truly affect change in the real world.
Okay, tools for action.
And the real game changer here is how this standardizes the interface. It allows for true reusability across any AI model. Imagine building a specialized tool, say an MCP server that handles all your straight payments. You build it once.
Just once.
Just once. And then any compliant AI model, whether it's from Anthropic, OpenAI, Google, doesn't matter. It can discover and use it. That's incredible agility.
Wow. Okay, that tackles that MXN problem head on.
Precisely.
So we've laid the groundwork for what MCP is and the big picture of its framework. Now let's dive deeper into P is for protocol, forging the connection.
Right.
You mentioned the core MCP architecture follows a client-host server pattern. Can you break that down a bit?
Sure. So the host is the application where your large language model, your LLM, actually lives. Think of an AI-powered IDE like Cursor or your Claude desktop assistant.
Okay, the user-facing app, basically.
Yeah, generally. It's the grand orchestrator. And crucially, it acts as your security gatekeeper. We'll come back to that.
Right.
Then you have the client. This is usually a lightweight piece, a sort of universal translator embedded within that host. Its job is to manage a dedicated connection to a single MCP server, sending and receiving structured JSON-RPC messages.
Okay, the translator talking to one server.
Exactly. And finally, the server itself is an independent program. It acts as a wrapper around some external system, could be a database, a third-party API, even your local file system.
Like the Stripe example.
Exactly like the Stripe example. It exposes that system's capabilities as standardized tools, resources, and prompts that any MCP client can immediately understand.
I see. And this separation, this architecture, you said it's good for modularity and security.
It's a huge win for both. Server developers can just focus on exposing their services capabilities. They don't need to worry about which LLM or host app will connect.
Right.
And conversely, host developers can integrate a vast array of tools without writing custom integration code for each one. It truly tackles that glue code problem we started with.
Okay, makes sense. And the communication itself, you mentioned JSON-RPC 2.0. What's important about that?
Think of it like a very strict, highly transparent business contract for communication. It specifies 3 main message types. Requests, which always expect a clear response back.
Okay.
Responses, which deliver either the result you wanted or a specific error message.
Here's success or failure.
Exactly. And notifications, which are just one-way messages, like a simple heads up, no response needed.
Gotcha.
And the entire connection follows a predictable life cycle. Initialization, where they sort of introduce themselves and declare capabilities. Operation, the normal back and forth. And termination, for a clean shutdown.
That structure seems really important, especially the error handling part.
Oh, it's vital. In complex agentic loops, where many tools might be invoked one after another, quickly diagnosing why an action failed becomes paramount. JSON-RPC's clear contract makes debugging these interactions vastly more transparent than trying to parse, ad hoc text outputs. Big operational advantage.
Right. And the actual connection, the transport layer, you mentioned 2 options.
Yeah, MCP is flexible there. It offers 2 primary mechanisms. First is STDIO, standard input-output.
Okay.
That's used for local inter-process communication, like when an AI needs to access your local file system. Its big advantages are simplicity and inherent security because it doesn't open any network ports.
So secure by default for local stuff.
Pretty much. Then you have HTTP plus SSE, that's HTTP with server-sent events. This is used for remote network services, like connecting to cloud-based APIs.
More common web approach.
Right. It's powerful, highly scalable, but, and this is important, it requires robust network security. We're talking TLS encryption, strong authentication, the works.
That choice between local and remote communication feels fundamental. For someone looking to get started, what's a common mistake you see people make when picking a connection type? And what's your go-to advice?
Yeah, good question. A common pitfall is honestly overcomplicating things early on.
Wow.
For anything purely local or, tightly coupled within the same machine, STDIO is often perfectly sufficient and, like we said, inherently more secure because there's no network exposure. Don't add complexity you don't need.
Keep it simple if you can.
Exactly. But if you know you'll need distributed agents or you're connecting to cloud services, don't try to force STDIO to do things it wasn't meant for. Embrace HTTP plus SSE from the start, but, and this is the key advice, invest in proper network security upfront. TLS encryption, robust authentication, maybe OAuth 2.1 like we'll discuss later.
Don't bolt on security afterwards.
Please don't. Trying to retrofit security onto an insecure remote connection is just a nightmare waiting to happen.
That's a really practical point. Okay, so we've established the rules of engagement with the protocol layer, the communication channels. But for an AI to truly be intelligent, it needs more than just a way to talk. It needs to understand its environment, to have its senses, as it were. That brings us perfectly into the C in our framework. C is for context, empowering models with knowledge.
The perception layer.
Right. So the primary primitive here for exposing read-only data, think of it like a DT request for an API, is called resources.
Okay, resources for data.
Yep. And there are 2 main types. You have static resources for data that's fixed or changes very infrequently, like configuration files, maybe company policy documents.
Stable information.
Exactly. But where the real power lies, I think, is in dynamic resources. These allow for on-demand retrieval of specific up-to-the-minute data.
Ah, the live stuff.
Yeah, often accessed via these intuitive URIs like users.userprofile to fetch a specific user's details right when needed. The SDKs make it pretty easy to define these. Connecting your AI directly to live, changing data sources.
Super useful. And complementing resources, you have prompts.
Okay, prompts. What are these exactly?
These are reusable, server-defined templates for structuring the interactions with the LLM.
Templates for talking to the AI.
Essentially, yes. They're critical because they enforce consistency, quality, and they can encapsulate best practices for complex workflows. Instead of you, or the AI, crafting a complex prompt from scratch every single time.
Which can be error-prone.
Very error-prone. You can simply invoke a predefined, well-tested prompt from the server. Think of it like using a really well-designed form rather than writing a free-form letter every time.
Okay, standardization again.
Exactly. SDKs and frameworks make defining these prompts straightforward. You can set up reusable templates even for quite complex multi-turn conversations.
I see.
And if we connect this back to the bigger picture, prompts are really about guiding the AI to behave predictably and produce consistent outputs. That's absolutely vital for enterprise applications where reliability, compliance, predictability, these are non-negotiable.
Makes total sense.
Yeah.
You need that control. Okay, fascinating. So if context gives AI its senses and understanding, the next logical step is giving it the ability to do something, to act.
Right.
That brings us to M is for model, giving AI the power to act. This is where the AI gets its hands.
Time for action.
So tools are essentially executable functions that an LM can discover and invoke. You can think of them like making a post, put a D, or delete request to an API.
Actions that change things.
Precisely. These could be anything from creating a file on your system, sending an email or a Slack message, querying a database for some detailed analysis, or even triggering an entire CI/CD pipeline for software deployment.
A huge range of possibilities.
And the genius part, I think, is that the AI model doesn't need hard-coded knowledge of these tools beforehand. It learns about them at runtime by inspecting their schemas.
Dynamically discovering capabilities.
And that brings us to an absolutely critical point. Schema is everything. You mentioned that earlier, and I can really see why now. But for someone less familiar with API design, maybe, could you explain why that machine-readable contract, the schema, is so absolutely critical for these AI models to function reliably? What happens if a schema is, say, poorly defined?
That's a great question because a schema truly is the bedrock of reliable AI actions. It's not just metadata, it's the instruction manual.
Right.
It's the machine-readable contract that tells the LLM three vital things: what the tool is, its name, what parameters it needs, including their data types like string or integer, and whether they're required or optional.
The inputs.
Right. And crucially, what it actually does, usually through a clear human-readable description that the LLM uses for reasoning.
Got it. Name, inputs, purpose.
Exactly. Now, if the schema is poorly defined, it's like giving someone a blueprint with missing dimensions, or worse, incorrect instructions.
Disaster waiting to happen.
Pretty much. The AI might try to call the tool with the wrong parameters, maybe a string instead of a number, or it might miss a required parameter altogether. Or it might misunderstand the tool's purpose and try to use it for the wrong task.
Leading to errors or just weird behavior.
Exactly. It can lead to runtime errors, unpredictable behavior, or even those infamous hallucinations where the AI thinks it successfully completed an action but actually failed, all because it couldn't correctly interpret the tool's capabilities from a faulty schema.
So precision in the schema is key.
Absolutely. Modern development frameworks, like those using pipe hints in Python with Pydantic, or, say, Zod schemas in TypeScript with those critical describe annotations, they provide robust ways to define these schemas, ensuring that necessary precision and clarity.
Okay, schema is everything. Got it.
And this is where it gets really interesting. The agentic loop in action. This isn't just the AI calling a function. It's a sophisticated multi-step process for an AI agent to actually use a tool, and it's all orchestrated by the host application.
The loop. Okay, walk us through it.
Okay. First step, discovery. The client asks the MCP server, hey, what tools do you have available and how do they work? The server sends back all the schemas for its tools.
So the AI learns what's possible.
Exactly. Then comes reasoning. The host takes your user prompt, like, what is the current stock price of Apple Inc., and sends it, along with those tool schemas it just received, to the LLM.
Feeding the options to the brain.
Right. The LLM then figures out, aha, based on the user's request and the available tools, I need the get stock price tool, and the argument I need to provide is ticker AAPL.
Okay, it forms a plan.
It forms a plan. But here's the crucial part, and this is truly transformative for safety and control. Approval. human in the loop.
Ah, the safety net.
A critical safety net. The LLM doesn't just go ahead and execute its plan. It returns its intent, I want to call get stock price with ticker AAPL, back to the host.
Okay.
The host application then presents this intended action directly to you, the human user. You see something like the AI wants to call get stock price ticker AAPL, allow.
So I get the final say.
You get the final say. Explicit approval. This is your final security gate. Only after you click allow or confirm does the host instruct the client to send the formal JSON-RPC request for that specific tool call.
That's huge. Okay, what happens after approval?
Then comes invocation, the formal request goes out, followed by execution. The MCP server receives the request, validates it against its schema one last time, and then executes the actual function. Maybe it calls a live financial data API in this case.
Gets the raw data.
Gets the raw data. Finally, synthesis. The server sends the result, say the raw stock price data, back through the client to the host. The host then passes this raw data back to the LLM, often with another prompt like, okay, here's the result. Now synthesize a natural language answer for the user.
Ah, so the LLM turns the raw data into something understandable.
Exactly. The LLM then generates the final, human-readable answer like, the current stock price for Apple Inc., AAPL, is $173.22.
Wow. That whole loop, especially that approval step, the human in the loop, that's truly fascinating. It's
Yeah.
not just the AI blindly executing. There's that critical oversight.
It's fundamental. This entire loop is the basic pattern for building powerful, yet reliable and safe agentic AI systems that can actually interact with the world and get things done.
With guardrails.
Okay.
That makes a lot of sense.
Yeah.
Now let's talk about something incredibly powerful that builds on this. Live RAG.
Ah, yes. Retrieval augmented generation, but live.
Right, this is RAG, but in the context of MCP, where an AI agent doesn't just rely on, say, pre-indexed documents in a vector database.
Which can get stale.
Exactly. Instead, it performs RAG directly from a live database or some other external system, querying fresh, structured information on demand using those MCP resources and tools we just discussed.
Yeah, live RAG is a significant leap, I think, beyond traditional RAG. Like you said, traditional RAG often involves pre-processing data, embedding it, putting it into a separate vector store.
Which takes time and can be outdated.
Right. Live RAG basically bypasses those intermediate vectorization steps entirely for the retrieval part. The AI uses an MCP resource or tool to query the source system directly. This ensures the AI is always working with the freshest, most accurate data possible.
And where is that particularly useful?
Oh, anywhere real-time information is critical. Think financial trading analysis, real-time customer service support using the latest account data, maybe dynamic inventory management in e-commerce. Anywhere where even minutes-old data can be irrelevant or misleading. Up to the second accuracy is key.
We can actually illustrate this with an example right from the source material. Building a live RAG financial analysis agent.
Yeah, that's a good one.
So you'd set up your project, maybe using Python, and have a simple SQL database, let's say, containing constantly updated stock prices and financial news snippets.
Okay, a live-ish data source.
Right. For the context layer, your MCP server would expose something like news.ticker as a dynamic resource. When the AI needs news for, say, Tesla, it hits this resource.
Which triggers a query directly against the database for the absolute latest TSLA news.
Exactly, on demand. And then for the model's toolbox, the MCP server could add tools like calculate moving average or get price range. These tools would perform calculations directly on that livestock data fetched moments before.
Combining live retrieval with live computation.
Precisely. Finally, you'd have an agentic client, maybe using an orchestration framework like LangChain or LangGraph. This client brings it all together. It connects to your MCP server, and based on a user query like summarize TSLE's performance over the last 30 days, including its 20-day moving average and any recent news.
The orchestrator guides the LLM to autonomously call the right resources, use.tsla, and tools, calculate moving average, get price range, in the right sequence.
Pulling live data, calculating on the fly, and then synthesizing that final summary.
That's the power of live RAG via MCP. Always fresh, always relevant.
It's a really compelling example. But, okay, moving from these powerful prototypes, maybe running on a developer's machine, to real-world enterprise deployment. That brings up some serious operational challenges, doesn't it?
Oh, absolutely. You hit the nail on the head. We're talking about security, observability, scalability, the bread and butter of enterprise software.
Let's tackle security first, especially for those remote HTTP-based servers. Authentication sounds critical.
Paramount. You simply cannot expose enterprise capabilities over the network without robust authentication. The industry best practice here is generally OAuth 2.1, specifically with the PKCE extension for added security.
Oath 2.1 with PKCE.
Yes, and ideally, you delegate the actual user authentication part to your existing enterprise identity provider. Think Microsoft Entra ID, Google Identity, Okta.
So leveraging existing logins.
Exactly. This ensures that the AI agent, when it acts through the MCP server, is only performing actions that you, the logged-in user, are actually authorized to perform within your organization's policies. It inherits your permissions, which is critical for compliance and trust.
That makes sense. The AI acts on my behalf with my permissions.
Precisely. And beyond authentication, we need a multi-pronged approach to threat mitigation. There are several risks specific to these kinds of systems.
Like what?
Well, prompt injection is a big one. You must treat all data retrieved from external resources as potentially untrusted input. Sanitize it rigorously before passing it to the LLM for reasoning or synthesis. Implement prompt shielding techniques.
Don't trust external data blindly.
Never. Then there's credential exposure. Please don't hard-code API keys or database passwords directly into your MCP server code. Use dedicated secrets management solutions like HashiCorp Vault or your cloud provider's secrets manager.
Standard best practice, but crucial here.
Absolutely. Also, excessive permissions. Always adhere strictly to the principle of least privilege. Tightly scope the permissions for the service account or credentials your MCP server uses. Does it really need write access to that entire database or just read access to specific tables?
Limit the blast radius if something goes wrong.
Exactly. And finally, think about unverified third-party servers. As MCP adoption grows, you might be tempted to use servers built by others. You need a formal governance process, maybe a vetted internal repository for approved, trusted MCP servers to mitigate supply chain risks. Don't just connect to any random server you find online.
Wow, that's a lot to consider on the security front. What are some of the biggest challenges you see organizations face when trying to implement these measures for AI agents? It sounds like it goes beyond traditional software security in some ways.
You're right, it absolutely does. I think the biggest challenge is the dynamic, almost unpredictable nature of the LLMs themselves. Traditional security often focuses on preventing known bad inputs or locking down static workflows.
Right.
But here, the AI itself is generating requests based on its reasoning, and the data it consumes to make those decisions can itself be manipulated through resources. So the challenge is shifting from purely static defenses to continuous validation, runtime monitoring, and anomaly detection.
More dynamic defenses for dynamic systems.
Exactly. It requires a different mindset, one that accepts the AI as a powerful but potentially unpredictable actor and focuses on building strong guardrails around its capabilities, its data access, and especially that human approval step for sensitive actions. It's less about preventing every possible bad input and more about safely managing the AI's actions and outputs.
That's a really insightful way to put it.
Yeah.
Okay, beyond security, observability is key. Making these agentic AI systems less like mysterious black boxes.
Hugely important. You need to understand what they're doing and why.
So tracing comes into play here, right? Using application performance monitoring APM tools.
Yes, absolutely. Tools like New Relic, Datadog, Honeycomb, they can be adapted or specifically designed to visualize the agent's entire decision-making process. You can see the sequence of tool or resource invocations, the actual inputs and outputs for each step, the latency.
See the whole chain of thought, almost.
Yeah. Exactly. It gives you incredible insight into why the AI made certain decisions, where bottlenecks are occurring, or where errors originate in that agentic loop. It's invaluable for debugging and optimization.
And for ongoing monitoring, what are the key metrics, the KPIs?
Well, you'd want to track standard things like tool latency, how long each action takes, tool error rate, how often actions fail, and maybe tool usage patterns, which tools are being used most often.
Okay, operational health.
Right. But critically, especially with LLMs involved, you need to track token consumption, both for the reasoning steps, where the LLM decides what to do, and the synthesis steps, where it generates the final answer. Tokens directly translate to cost with most powerful models.
Keep an eye on the budget.
You absolutely have to. Understanding token usage per task or per agent interaction is crucial for managing operational expenses.
Makes sense. And finally, for getting these things running reliably at scale.
It really comes down to leveraging standard, robust DevOps practices. This includes containerization with tools like Docker, packaging your MCP servers consistently, using orchestration platforms like Kubernetes, or maybe serverless options like Google Cloud Run or AWS Fargate for managing instances. scaling them up or down automatically based on demand.
Standard cloud native stuff.
Pretty much. And of course, robust CI/CD pipelines for automated testing and safe, repeatable deployments of both your MCP servers and your host applications. You want to be able to update capabilities quickly but safely.
So it's about applying proven software engineering discipline to this new AI paradigm.
Precisely. If we connect this to the bigger picture, these operational practices, security, observability, scalable deployment, they're what transform a clever prototype into a robust, reliable, production-grade service that businesses can actually depend on.
That's the goal. Okay, all these technical implementations, the monitoring, it all leads to one critical question. How do we know if our AI is actually working well? Is it effective?
Yeah, the evaluation piece, it's crucial.
This emphasizes the importance of rigorous quantitative evaluation, moving far beyond just subjective, yeah, that answer looks pretty good assessments.
Absolutely. Looks good, doesn't scale, and it doesn't catch subtle failures. For proper evaluation, you typically start by creating a golden data set.
A golden data set.
Yeah, this is a carefully curated set of input questions or tasks, along with their corresponding known ground truth answers or desired outcomes. This is your benchmark.
Okay, the correct answers.
Right. Then you can use automated frameworks, like Ragus is a popular one, which cleverly leverage other LLMs as judges to score the quality of your AI system's outputs against that golden data set across various metrics.
Using AI to evaluate AI. Interesting.
It can be surprisingly effective and much faster than manual review for large data sets. But what's particularly valuable, especially for these complex live RAG systems we discussed, is performing component-level evaluation.
Breaking it down.
Exactly. You meticulously separate the evaluation of the retrieval process, getting the context, from the generation process, synthesizing the answer. This allows you to pinpoint the exact root cause if the overall quality isn't good enough.
Find where the problem lies. How does that work?
So, for retrieval metrics, which focus on the context provided by your MCP tools and resources, you'd measure things like context precision. That's basically the signal-to-noise ratio. Did the retrieved information actually help answer the question, or was a lot of irrelevant stuff fetched?
Okay, precision relevance.
Mostly, yeah. And then context recall, did we retrieve all the necessary information needed to answer the question thoroughly, or is critical data missing?
Recall. Completeness.
Right. Now, if these context metrics are low, you know the problem likely lies with your MCP server's resource or tool logic. Maybe the SQL query in your resource is wrong, or the tool isn't fetching the right data fields. You fix the server.
Target the fix on the data retrieval part.
Exactly.
Yeah.
Then separately, you look at generation metrics. These focus purely on the LLM synthesis step, assuming it got good context. Here, you measure faithfulness is the generated answer factually accurate based only on the provided context. Are there any hallucinations, meaning did the model make things up?
Sticking to the facts provided.
Crucial. And answer relevancy, how well does the final synthesized answer actually address the user's original question? Did it stay on topic?
Okay. Faithfulness and relevancy.
Right. Now, the key insight here is, if your generation metrics, faithfulness, relevancy, are low, while your context metrics, precision, recall, are high, then you know the issue isn't with the data retrieval.
The problem is the LLM step.
Exactly. The issue is likely with the prompt you use to ask the LLM to synthesize the answer, or potentially with the choice of the LLM itself. Maybe a different model would be better at that specific synthesis task.
That's incredibly useful for debugging. You know where to focus your improvement efforts.
Precisely. This iterative evaluation approach, build, measure components, diagnose, improve, is incredibly powerful. It helps you systematically enhance reliability and performance rather than just guessing what's wrong.
So what does this all mean for building reliable AI in the long run? It feels like we've covered a lot of ground.
We have. It's a big topic.
What we've really seen today, I think, is the profound significance of something like the Model Context Protocol. It feels like it's truly shifting AI from these isolated, often brittle models
Siloed capabilities
to a vibrant, interconnected ecosystem. MCP seems to directly solve that frustrating MXN integration problem we started with,
It provides that standard interface.
enabling us to build scalable, maintainable, and genuinely powerful AI systems that were, frankly, almost unimaginable before. It gives AI agents the ability to perceive, reason, and act with unprecedented capability, but also, importantly, with safety mechanisms built in.
Yeah, we've explored that core MCP framework. We dove into the protocol layer, establishing the rules of engagement, the communication. We looked at the context layer, empowering models with knowledge through resources and prompts, the senses, and the model layer, where tools give AI the power to act the hands. We also touched on practical applications like Live RAG for real-time data access, and those critical enterprise considerations, security, observability, evaluation, needed to move from a cool prototype to production reality.
It's definitely more than just a technical spec.
Oh, much more. It feels like a fundamental re-architecture, a new pattern for how AI will integrate into software and into our workflows.
And looking ahead, the future of this MCP ecosystem seems incredibly exciting, doesn't it?
I think so.
We're probably on the cusp of seeing vibrant marketplaces emerge for off-the-shelf MCP servers. Imagine just browsing and plugging in capabilities.
Like an app store for AI skills.
Exactly. Allowing AI agents to dynamically discover and then chain together tools from multiple disparate servers. Maybe one for travel booking, another for financial analysis, a third for project management to solve incredibly complex multi-domain problems.
That vision of a truly collaborative, composable, and autonomous agentic AI mesh, where different specialized AIs work together seamlessly, orchestrated perhaps by a host application to tackle complex challenges.
It no longer feels like just a science fiction concept.
No, it feels like the logical next step in AI integration. And it's being built on foundational standards like MCP.
So maybe a final thought for our listeners. What's the key takeaway?
I think the key takeaway is this. The future of truly intelligent, impactful applications probably isn't just about building ever bigger, all-knowing, monolithic models.
Right.
It's increasingly about connectivity, interoperability, and the sophisticated orchestration of specialized agents that can perceive, reason, and act safely in specific domains. Understanding and mastering the principles behind protocols like MCP and the frameworks for building agentic systems around them feels essential for anyone looking to build the next generation of intelligent, enterprise-grade applications that will really define tomorrow.
Connectivity, interoperability, orchestration. That's a great place to leave it. Thanks for breaking all that down.
My pleasure. It's fascinating stuff.